In question 13, we're told that signals are transmitted from one neuron to the next neuron by molecules. So this is what we're told, and then we have a series of statements about this process which we have to assess whether or not they're correct. Before we come to those statements, let's quickly talk through what the process of this signal transfer from neuron to neuron involves. So we have the two ends of our neurons between which there will be transfer. So we have our presynaptic neuron, our postsynaptic neuron, and a synapse in the middle, of course. The synapse is the gap by which this neuron to neuron transfer is mediated, and mediated by molecules. So we should know that in our presynaptic neuron we have a number of vesicles, and within which we have neurotransmitters. These neurotransmitters are these molecules that we're talking about which mediate signal transfer. So I'll quickly talk through the process. There is an impulse which arrives at the end of the presynaptic neuron, which we want to get to the postsynaptic neuron. We should know that this impulse is composed of an elevated sodium concentration, which leads to a depolarization, i.e. a change in the electrical potential of the presynaptic neuron. Some of these details you may not have come across, but the basic bones you should be familiar with. Okay, so what this increase in sodium concentration, i.e. this depolarizing impulse, should do is lead to calcium entering the terminal of the presynaptic neuron. What this calcium does is lead to neurotransmitters coming towards the terminal membrane of the presynaptic neuron as follows, and there is some neurotransmitter which gets leaked into the synapse. From this point there is diffusion of this neurotransmitter, where it then binds to neurotransmitter receptors on the postsynaptic neuron. Upon binding, there is movement of sodium into the postsynaptic neuron, and that in turn leads to a depolarization and a transfer of the impulse to the postsynaptic neuron. So now that we've been through this process, let's have a look at our 5 statements. We'll start with statement 1, which is that transmitter molecules are formed in the receptors. Well, we can see the receptors here, and the transmitter molecules aren't formed here, they're formed in the presynaptic neuron and then end up binding to the neurotransmitter receptors. So we can say this is false. The second statement is that signal is transmitted across the synapse by osmosis. Now, osmosis refers to the movement of water molecules alone, down a water potential gradient. In fact, what we see here is diffusion of neurotransmitter molecules, so we can say this is false. Moving on to 3, the transmitter molecules are released once the signal has been transmitted across the synapse. So this is saying that the transmitter molecules are only released once the signal has been received on the far side. But we know that this has to be wrong, since it's the transmitter molecules themselves that mediate the transfer of the impulse. So the impulse comes at the very end. Moving on to 4, we've already talked about how the release of transmitter molecules is triggered by the impulse, which leads to an influx of calcium ions. And finally, we should know that the transmission across the synapse is mediated by diffusion. So we have our answer, which is that 4 and 5 are correct, and therefore our answer must be option F.